Hello Candles, welcome to yet another session of Candela Learnings. I am Gina, your math super tutor. I hope you are all doing well and are having a great day. So students, today we are going to discuss an interesting topic, that is frustum of a cone from the chapter surface areas and volumes. So without wasting any more time, let's get started. So on the slide, you can see a basic solid, a shape. You must be very familiar with it, right? So tell me the name of the solid. Yes, it is a right circular cone, right? Now this cone is sliced by a plane parallel to the base, okay, as you can see in the picture. Now the two parts separated. Now the bottommost part, that is a smaller right circular cone, is there, right? That part is removed. Now look at the shape of the remaining part. Yes, it is known as frustum of a cone. In this particular session, we are going to discuss the surface area and volume of frustum of a cone. So yes, if you look around, you can see many objects that are in the shape of frustum of a cone. For example, a table lamp. Yes, it is in the shape of a frustum of a cone, right? Then bucket, tumbler, we'll be using these things in our day-to-day life, right? So yes, we can definitely say that these objects are in the shape of frustum of a cone. If you observe, you can see more and more objects in this particular shape. Now let's talk about surface area of frustum of a cone. Okay. So here you can see, in a frustum of a cone, we have a curved surface, right? At two ends, we have two circular flat surfaces as well. Okay. Now the bigger circle is having a radius R1, and the topmost circle, which is a smaller circle, right? It is having radius R2. And the height is H, and it is having a slant height, which is denoted as L. Okay. Now CSA of frustum of cone will be equal to pi into R1 plus R2 into L. Now TSA stands for total surface area, right? Along with the curved surface area, we have to add the base as well as the top area. Okay. So TSA of frustum of cone, that is total surface area of frustum of cone, is equal to pi into R1 plus R2 into L. That is nothing but our CSA, right? This is our CSA, plus the area of the base, that is pi R1 square, plus area of the top, that is pi R2 square. Yes, we know area of a circle, right? That is pi R square. So that's it. That would be the formula to find the total surface area of frustum of cone. Okay, where L is our slant height, that is equal to root of h square plus R1 minus R2 the whole square. Now let's talk about the volume of frustum of cone. Okay, so volume of frustum of cone will be equal to 1 by 3 pi h into R1 square plus R2 square plus R1 R2. So yes, so these formulas are derived from the idea of similarity of triangles. So we don't have to learn the derivations here, just use the formula to find the surface area of frustum of cone and the volume formula to find the volume. Moving ahead, we have a question here. Let's solve the question using the formula. So let's read out the question first, then identify the keywords and we can solve it. The question is, a drinking glass is in the shape of a frustum of a cone of height 14 cm. The diameters of its two circular ends are 4 cm and 2 cm. Find the capacity of the glass. So look at the shape of the glass. Yes, definitely it is in the shape of frustum of a cone, right? Okay, so here we can say that capacity of the glass is equal to volume of frustum of a cone. Now, do you remember the formula to find volume of frustum of a cone? Yes, we all know the formula, right? So let's write that then. Volume of frustum of a cone is equal to 1 by 3 pi into R1 square plus R2 square plus R1 R2 into H. Yes. Now, do we have the variables, that is R1, R2 and H with us? Let's check. So look at the rough figure we got, okay, where R1 is the radius of the bigger circle, right? So that is the topmost part. Here we are provided with the diameter, that is 4 cm. So from that we can easily find out the radius, right? Just half of it, that is 2 cm. So we got the value, this is nothing but our R1. R1 is equal to 2 centimeter. And if you look at the bottommost part, there also we have a circle, right? So there the diameter is 2 centimeter. So the radius will be 1 centimeter. So R2 can be denoted as 1 centimeter. And H is also given in our question, that is 14 centimeters. So this is our H. So we have the values, R1 is equal to 2 centimeter. R2 is equal to 1 centimeter and H is equal to 14 centimeter. So let's substitute these values in our equation. So yes, volume is equal to 1 by 3 into pi can be replaced by 22 by 7 into R1 square, that is 2 square plus R2 square 1 square plus 2 into 1 into H is 40. That is equal to 1 by 3 into 22 by 7 into 2 square is 4, 1 square is 1 and 2 into 1 is 2. So, we will be getting 4 plus 1 plus 2 into 14. Again 1 by 3 into 22 by 7 into 4 plus 1 plus 2 is 7. So, into 7 into 14. Okay. Now, let us simplify this. 7 and 7 can be cancelled. We will be getting 22 into 14 by 3, that is equal to 308 by 3, that is equal to 102.66 centimeter cube. So yes, we got the answer. The answer is 102.66 centimeter cube. This will be the capacity of this glass. Pretty easy, isn't it? Okay. Now let's get into the next question. First, the cap used by the Turks is shaped like the frustum of a cone. If its radius on the open side is 10 centimeter, the radius at the upper base is 4 cm and its slant height is 15 cm. Find the area of material used for making it. So first of all, let's mark the keywords. So this is a cap, right? This particular cap is in the shape of frustum of a cone, as you can see in the picture. Okay. Now, if its radius on the open side, that is for a cap there would be an open side, right? So yes, it is 10 centimeter and the radius at the upper base is 4 centimeter. Radius is already given. Now slant height is also given as 15 centimeter. Find the area of material used for making it. Area of material used for making it means total surface area. We have to find it. Okay. So yes, 10 centimeter is R1, right? We know radius of the bigger circle, that is R1, is equal to 10 centimeters. Now topmost part, it is having a radius of 4 centimeter. So this is R2. R2 is equal to 4 centimeter. And slant height, we always denote it using L, right? L is already given, that is 15 centimeters. So we have all the data with us. We have to find the surface area, that is total surface area. Do you remember the formula to find the total surface area? Okay. So TSA, total surface area, is equal to, what is the formula? Curved surface area plus the base area plus the top area, right? Okay. So curved surface area, that is pi into R1 plus R2 into L plus base area, that is pi R1 square plus pi R2 square. But here you have to be careful. This is a cap. So the bottommost part would be an open side, right? So we don't have to consider the area of the bottommost face, right? So yes, that's it. So the total surface area for this particular case would be the curved surface area plus area of the top. That's it. So we don't have to consider pi R1 square. So here the total surface area is equal to area of curved surface plus area of the top face. That's it. So that is equal to pi into R1 plus R2 into L plus pi into R2 square. Yes, that's it. Now let's replace our pi by 22 by 7. R1 plus R2, that is 10 plus 4 into L is 15 plus again 22 by 7 into R2 is 4, right? So 4 square. Simplifying, let's take out 22 by 7 outside. So we'll be getting 10 plus 4 is 14. 14 into 15 plus 4 square, that is nothing but 16, right? So here we'll be getting 22 by 7 into 210 plus 16. 22 by 7 into 226, that is equal to 710.286 centimeters square. Yes. So this will be the total area required to make the cap. So yes, let's write. The area of material used for making the cap. The area of material used for making the cap is equal to 17.286 centimeters square. That's it. I hope this question is very clear to everyone. So students, it's time to wind up. So yes, in this particular session, we have discussed how to find the surface area and volume of a frustum of cone. So yes, I'll see you in another class. Till then, keep learning. Bye-bye.